my name is Espen Volden. So I'm working in ESA Esrin as Magda in Irene, which is a kind of Earth Observation Center of ESA. We have the center in the Netherlands, the biggest site of ESA, which is also an Earth Observation Center, but there is where they develop the satellites. While in Esrin, in Frascati, outside Rome, we are taking down the data, distributing them, and doing activities to try to boost the use of the data. So I'm working not in the department where we are taking down the data, the ground segment department, but the other department there, which is called Earth Observation, Science, Applications, and Climate. And inside there, I'm in what we call the Earth Observation Data Applications Division, and in the Science section. So I will tell you about first a bit about ESA, a bit more about our center in Italy, Esrin, and about our Earth observation program. Then I will introduce a little bit to the Copernicus program before coming to our Earth Observation for Society program, where we are developing new applications and service and science to benefit the society. And it will also present you some opportunities also for you within this program. So what is ESA? ESA is about promoting cooperation about European states, so in space research, technology, and applications, and it's only for peaceful purposes. We have a total workforce of 5,500 people working on different sites, and the total budget, as an example, for 2023 is about 7 billion, which is a huge number, of course, but we like to divide it by the number of people in Europe, so that it's only 12 euros per European citizen per year. So we're talking about a dish in a restaurant, approximately. I don't go through all these numbers here. It was just to show that out of the 7 billion, Earth observation represents here 1/4 of the budget, so almost 1.8 billion in 23. We have 22 member states now, so we are kind of moving slowly towards having approximately the same member states as the European Union, but with some additional important member states, Switzerland and Norway. I say that because I'm Norwegian myself. So we have today 22 member states, 4 associate members who are becoming members, and we have a cooperation agreement with 6 other European states and with Canada, so that they can also participate in our programs. We have a number of locations. We have sites where ESA staff are working in different European countries. And we also have some ground stations, data taken down, and some offices also outside Europe. So coming to our Esrin site in Italy. So the main activity in this site is Earth observation, as I mentioned. So most of the buildings that you see here are full of people working on Earth observation. We have we'll come back to it later, a science hub that you can see over here. We have a phi lab somewhere here, yes. And then we have also some activities as with the disaster charter coordination center, which is a kind of 7 days a week, 24 hours center for when there is an important emergency somewhere to launch Earth observation activities to try to support. We have also space transportation, Vega launcher. We have ESA security office, etc. So altogether, we are approaching 1,000 people on the site now, and we have around 50,000 visitors every year. So I think I said most of this, but main activities, building satellites in the Netherlands, and then in Esrin working on managing these missions, taking down the data and distributing them. We have activities on calibration, validation of the data before distributing them. And then we have different program elements for the applications of the data, and some other ones related more to innovation and commercialization. So I mentioned this disaster charge coordination center, which is operational all the time, with approximately 40 activations per year. So there are some mandated organizations in many countries around the world that can activate this charter, so that some institutes and companies will start working on supporting the disaster with the Earth observation data. So the main goal of ESA Earth observation is to develop really world-class satellite missions, and that should be useful both for science and for operations in society. Up to now, we have built or are building or have built up 77 missions, of which most of them are being developed now, but we also 14 in operations and 4 that are now history. These are in 3 different strands. So the first to the right here, you see the strands for meteorology. These are operational satellites where we're working together with EUMETSAT. EUMETSAT is providing us with user requirements for these satellites. And then ESA is detailing this into more specific requirements, and then building the satellites, launching them, and then handing them over to EUMETSAT again for operating them. So that's for the meteorological satellites. Then you have the also operational Copernicus satellites. So where it's the Commission is leading the whole Copernicus initiative, and ESA is in charge of the space segment. So a number of satellites that has really increased a lot the Earth observation activity of ESA. And I'll get back to the Copernicus later. And then the last is the science strand. Which is what we call the Earth Explorer missions. So these are satellites that are kind of more one-off. It's not, when we launch them, it's not a plan to have a series of satellites like for Copernicus. They are built to address some specific scientific challenges, and if they become successful, maybe in the future they will become, or some follow-up will be a part of Copernicus. But for the moment, it's just something to try to address some important scientific challenges. And these satellites are therefore also very experimental. And we will get back to hear about one of them later today in the session, where we will hear about 7 different missions. One of them will be an Earth Explorer mission called FLEX, which is addressing the fluorescence, measuring fluorescence in order to measure the photosynthetic activity of plants, which is related to hydrology through droughts, because it can be you measure in this way the stress of the plants, which can come from drought. So these are the missions, and why are we doing this? It's because we want to address different agendas, environmental agendas, climate agendas, both global ones and European ones. So like the Sustainable Development Goals, the climate change agenda, the Sendai framework for environmental threats, and also in Europe, the European Green Deal in particular. So this is kind of how we can justify this mission, spending so much money on this mission, that we need to support really effectively these types of agendas. So going to Copernicus, this is really the program that has changed a lot the whole domain of Earth observation. We have a huge amount of data being produced every day and distributed. As you see here, 25 terabytes every day produced and 300 disseminated. And which is one really huge milestone of this, which we can now have every spot on land spot on the Earth visited every 5 days with 10-meter resolution data. So this is something that has really changed the way we can use Earth observation data. It means that we are not like in the past where we were working on one image. Now we're working on time series, and this has changed really a lot. So now in Copernicus, we have more than 700,000 registered users. And there will be also many other people who are using them because they get data from people who have registered. So it's a really huge number of users. We have 6 operational services. The Commission is in charge of this part of Copernicus, which is about services, which was mentioned from the ministry also, the Copernicus services. And we have today 7 Copernicus Sentinels flying. I will get back to those. And we are also developing what we call the expansion mission of Copernicus now, with 6 new ones. I'll also get back to that. And so I think what has really changed with Copernicus is that you have really excellent quality data. You have the huge number of data, the time series, and you also have the full free and open data policy. So with this, Copernicus effectively changed the game for Earth observation. So Sentinel-1, the SAR mission, you will hear a bit more about it later today. For our theme of this training course, so hydrology and hazards, this radar mission is very important. And we have the Sentinel-2, the multispectral mission, which is also very important for hydrology through different ways. And the Sentinel-3, which has both the more similar as multispectral imaging features, capabilities, but also thermal one, which is also very important for hydrology, for example, through evapotranspiration. And also has altimetry, so which is also important for hydrology in the sense that we can measure the height of different water bodies. And then the 3 first one is the clearly most important one for hydrology and hazards. So these are the ones that we will hear more about in this mission on this session on the mission status after the coffee break. And I said we are building 6 new families of satellites now. At least 3 of them are quite relevant for hydrology, but even a bit more. We have the Simmer passive microwave radiometer, which will give some contribution to soil moisture. We have the land surface temperature mission, so we will have thermal data, which will be really something of importance for agriculture, that we can now derive evapotranspiration at a scale which starts potentially to be useful for farmers. We have the CHIME mission, hyperspectral, which is really interesting for the soil, and from there that can have some help with also better understanding property soil, can help also for the soil moisture, and more indirectly be of help for hydrology in different ways. And then we have the ROSEL, the L-band SAR mission, which will complement Sentinel-1, which is another frequency, the C-band mission. So with this, we will have a better, for example, better estimation of soil moisture, amongst others. As I mentioned, in addition to the space segment, we have the services, so where the Commission is in charge. For hydrology, you have the Copernicus land monitoring services, which have, for example, biogeophysical parameters, both over Europe and worldwide, with soil moisture, snow, temperature, reflectance, vegetation, water bodies. So there are a number of projects here that are useful in hydrology. And there is also the Copernicus Emergency Monitoring Service, which have mapping elements and also early warning. So you see the web address is here. So that was for Copernicus. So now I will move on to what we are doing inside our Earth Observation for Science for Society program, where we are developing new applications and new science. Some of them move after that into Copernicus, but that's not it's not the main goal of our activities. It's to be beneficial for society in different ways, and one important is through scientific results. So what are we doing in EU for Science? We are engaging the community. We are, for example, organizing workshops. We do training and education, as we are doing here today. We develop new methods and observation products in projects. I will get back to that, and advancing Earth system science through the use of these new products. We are doing scientific campaigns to get, for example, in situ data, which are important for our projects. Can include also airborne campaigns. We are working on open science tools. You will hear more about several tools even today, in particular the Snap tool. We are also doing virtual labs to help work on the data and visualize them. We establish networking and partnerships, for example, partnerships with the big scientific organizations. So we have international ones, so that we have common agendas, identifying which are the important scientific challenges to address. And we try to feed from all this, we try to feed that also into new future missions. So coming to hydrology, what we're doing inside this EU for Science is that we are trying to help better understand the water cycle in different ways and through the different elements of it. This is the new water cycle. Was USGS had a kind of globally accepted water cycle diagram, which they updated last year, mainly in order now to take more into account the human component, the human impact on the water cycle, because that is becoming more and more important. So that you see now, in addition to the classical processes and elements, like you have precipitation over land, the transport of moisture from ocean to land, etc. Now we also have included agricultural water use, industrial water use, municipal water use, etc. Because this is becoming more and more important, has a bigger influence on the water cycle. So what are we doing in our projects in order to better understand the water cycle? We are developing new high-resolution products. So for different variables that are related to hydrology, we try to make products which are estimations which are as accurate as possible. We try to all the time increase the spatial resolution, the temporal resolution. So we have a number of projects where we're working. In each project, we're working on one single variable. So I will show you some examples later on some of this: evapotranspiration, soil moisture, precipitation, snow, irrigation, runoff, and river discharge. Snow, just to mention here, we have a project working on snow area extent, the albedo, grain size, wetness, snow mass, so the snow water equivalence, and snow depth. So we have trying to estimate a lot of different parameters of this now, which is of course important for the hydrological cycle. And also just an illustration here that we're also working on precipitation. Okay, you have global, for example, the Global Precipitation Mission can provide at the global level good information about precipitation, but we are trying to improve them so to have a better, for example, smaller, more intensive local events that we can also better observe them by including, for example, soil moisture information. So integrating that with the other data, then we are able to better also observe such more intensive and local phenomena. Evapotranspiration, I mentioned the Sentinel-3. We have a thermal sensor on it, so we can from that derive evapotranspiration at 1 kilometer resolution, as you see on the right. Then we have the Sentinel-2, which cannot provide evapotranspiration on its own, but it provides more detailed imagery at, for example, at 20 meters for several bands. And then we had this project where we tried to combine this in order to derive an evapotranspiration product at 20-meter resolution. And following the quite promising results, we started another project together with FAO, but they are trying to use that in their activities. Irrigation. We had there has been a number of projects in the past trying to map irrigation, where irrigation happens. But in this project, we tried also to determine how much irrigation and when it happened. So this is quite tricky, and this is a kind of first attempt where we see it's a very important subject, of course. 70% of the use of water is worldwide is for agriculture. And we see it also that there are lots of activities starting, lots of publication, and only from this project we had 26 international publications in peer-reviewed journals. So also see that we have projects which are really providing excellent science. And out of such project, we also got a number of data sets, and we demonstrated how these data sets can be used. As an initial demonstration for operational user, and also seeing how it can address science. So you can see here, for example, in the northern part of Spain, that you can see the amount of irrigation here. The darker it is, the more irrigation, up to more than 700 millimeter during a certain during the summer period, for example, here. So these are the first estimates that we have for the irrigation. On this, the amount of irrigation. We are not still there so that we can provide precise maps, but we are starting to get very promising results. And you can also get this type of animation here, but you can see also in northern Spain that you get how much during different years, how much irrigation is applied, which is very useful for those who, for example, manage the water of the basins. So I said we are doing these projects where we take one hydrology-related variable and we try to make as good product as possible. And then we have other projects where we have another spirit, which is about integrating different variables of the hydrological cycle, and from there try to reconstruct as best as we can the water cycle. So one example here is this 4D Med hydrology project, where we are concentrating on the Mediterranean basin. And we are making these nice data sets for each of the variables, but trying also to do it in a way that the data sets the variables are consistent. And then from there, also look at what we can use them for afterwards. So both still improving on the product, but especially trying to, here you see all the different products in this area of the Mediterranean. So snow, soil moisture runoff, precipitation, groundwater, root going from the surface soil moisture to root soil moisture, and the evapotranspiration. And then from there, try to see how we can solve some scientific problems about the snow in the Mediterranean region, about land-atmosphere interaction, about the human impact on the water cycle, and also about trying to attribute the irrigation water sources. And we also have some more practical, trying to see how it can also work, how it can also help more operational users. Okay, it's time for coffee breaks. I need to move faster. The step afterwards is that we move towards what we call the digital twins. So digital in Earth, we're talking about doing simulation of bio-geophysical processes on the Earth, So for the moment, what we are doing is that we're trying to doing that for for different elements of the Earth system. So here, hydrology is one. So we had a project to try to start on this. So you see that we put together all these different layers, like soil moisture, evaporation, precipitation, and from there, using modeling, we can estimate the river discharge, so we can get such simulations. And also what we can do is that we can then do kind of what-if scenarios. We can see what are the initial conditions today, for example, soil moisture and snow water equivalent, and then we can play with what happens if precipitation is like this in the coming days, air temperature will be like this, then what impact will it have for the water that is available, for example, for irrigation or other things. So this is next step. Also mentioned that we have some, we have activities specifically working on drought, looking at both on the vegetation, seeing the effect on the vegetation from the drought, but also looking at the soil moisture, for example, and the evapotranspiration. We're also looking at how we can use artificial intelligence in order to improve the understanding of the water cycle. So that we're kind of doing mix between these more hybrid models between artificial intelligence and physical modeling. So here's an example where we included a physical constraint within the neural network. As I said, there are some, we are working on workshops. That is also an opportunity for you. That this one, which will take place in Lisbon, 27 November to 1st of December, Hydrospace. It's too late to submit abstracts to get a poster there, but you're still welcome to register for the event. The Earth System Science Hub in Esrin, I mentioned it. So this is a place where we're trying to bring really the science into ESA, because much of our projects are being done outside in universities and research institutes. But here we bring the scientists into ESA, so both younger scientists, postdocs, but also more senior scientists, so that they can work on specific issues that are of interest for solving some challenges, scientific challenges. And we have a nice environment where we also have open science data tools. We have cloud computing and high-performance computing. There is an opportunity just now, a call out for postdocs. So closing date 3rd of October. So you see the link here. You can apply for such a postdoc fellowship to be 2 years in the Science Hub in Esrin. We have another opportunity, which we call the Living Planet Fellowship. It's also about postdoc contracts. These are not necessarily in Esrin; they can be elsewhere. But with this, it's also possible to have a part of it, maybe, for example, coming to Esrin in the Science Hub for 3 months, for example. So there is also a call out now with the deadline on 27th of October. So there are some opportunities here. And last thing we're doing, as mentioned, we're doing courses like this. So thank you very much.